Hi everyone. So Codejam has started again, and the qualification round is already finished for this year, as you can see. So I'm very excited. I prepared for the qualification round, and I solved a few problems. So in this video, I'm gonna show you how what are the problems and how to be solved. So let's just start right into it. So the first problem is problem's solution. So the problem is that without reading the problem, let me just tell you what the problem exactly is. So because you can always go back and read the problem through the Codejam website. So the problem is that they have a number. Okay, the number is n, and it contains the number might be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a number. So this number contains a 4 in it. Okay, so number might be 4444, which it has 4 4s in it, or 4004, it has 2 4s in it. Okay, so they have there is a number which contains a 4. Okay, at least one 4 is there in the number. What we have to do is come up with two numbers which does not have a 4 in it, and yet the two numbers add up to this number. Okay, so this is the whole problem that they are trying to describe. So they have given us a number n. We have to come up with two numbers a and b such that a plus b is equal to n, but a and b themselves don't contain any 4 in it. Okay, so and let's have a look at the test set. This is the most important things that you should pay attention to. That is the limits. What are the limits and what are the test set values. So as you can see that in test set 1 we have 10 to the power 5, that means 100,000, and can be as large as 100,000. Test set 2 is and can be basically as large as the range of integer, the max value of integer. And test set 3, which this is the key thing here, it can go up to 10 to the power 100. Okay, so this tells us that we cannot use int or long or any other such variable in our program. We have to use strings or big integer in case of Java. So that's that. So and they have given us an input and output, corresponding output. So this is the test case number. So we have 3 test cases in this example. The first one is 4. So the number is 4. So they have given us an output like 2 and 2. So 2 plus 2 is 4, and with 2, there is no 4 in this A or B. In this example, 940, it's 852 plus 88, which add up to 940, and they themselves don't have any 4 in it. Same 44444, which is 667, 3777, which add to 4444. Okay. So our job is very simple. We have been given a number, we just have to find the two numbers, okay, which don't have any 4 in it. So the way I implemented this is it's very simple. If you just think about the problem, it's not all that complicated. It's just asking us that the two numbers that don't contain any 4 in it. Okay, so the way I have implemented this is like I first of all I've used Java. You can use C or Python or any other language to work the same. Just the core logic you have to understand to be able to implement it in any language. So there I have taken I have got the calculator, take the input. I've taken the input, the test case numbers, and looked over all the test cases and got the original number and counted it to string buffer, and then this is the code logic. Okay, so what I've done here, let's have an example. Let's have an example of this number. It could be very big. Okay, so this is a number. It has 4, 1, 4 and 2, 4. Sorry, 2, 4 in it. Okay, so what we have to do is come up with another number that doesn't have any 4, and another two numbers which don't have any 4 in it. Okay, so what we can do is wherever we see a 4, we just convert this to a 3. Okay, and forget about whatever number the other number. We just wherever there is a 4, we convert to 3, and that's it. So in this fashion, if we go here, there we have 4, we convert it to a 3, and then the same. Okay, so then you ask, you have one number, what about the other number? What you have to do is, to get the other number, you just take this number and minus this number, so you will just get the number that you want. That's it. That's all. That is very simple. So here I have done the same thing, but I've run a loop from the end position to the first position. You can always run from the first position to the end position, doesn't really matter. So you have to run a loop over all the characters of the number, and wherever you find a 4, you just turn it into 3. Okay, and then you have the first number, and to get the second number, all you have to do is get the original number that was there, convert it to big integer, subtract the number that you have just got, and convert it to string. There you will have the two numbers that you need. Let's run this with an example that is there on their website. Okay, so there we have it. For the first number 4, we have a 3 and a 1, which is correct. For 940, see, it doesn't have to be this number only. It can be any number, any two numbers, as long as it follows the two criteria. That is, the summation of these two numbers should be the input number itself, and they should not contain 4 in themselves. Okay, so as long as the numbers that follow these two criteria, it is a valid answer. It doesn't have to match exactly with these answers. Okay, that is one thing that they have mentioned again and again in their website. So you see, it's 930 and 10, which added to 940, and don't contain any 4 in it. And the third is 4444. So we have 3, 3, 3, 3, and more. Okay, so that was a very simple program that they posted this year. Okay, so we go to the second problem, which is you can go your own way. Yes, so this is another well, if I rate the previous problem at around 2 out of 10, then this problem will be at around 2.5 maybe out of 10. Okay, so it is also very simple program. Okay, very simple problem. So let me just tell you what the problem is, instead of reading the whole paragraph, which you can always go back to the Codejam site and read yourself. So the problem that they have posed is that this is a grid of n cross n cells. Okay, and they will give as an input number. So in this case, it is 5 cross 5, so n is 5. In this cell, in this grid, this is the topmost cell, top left, and the bottom right. Okay, so we have to start at the top left cell and end up at the bottom right cell. Okay, and this is one path that is already given. This orange path is already given to you. Okay, so this is one path that someone has taken up. Okay, to go from here to here. What you have to do is go from here to here without taking any single path that this person has taken. Okay, so you can go this way, which is shown here. Okay, so one thing you cannot do is that once you are here, let's say you are here, and the person has taken this path to go from here to here, you cannot use the same path to go from here to here. Okay, you have to choose a different path. You just cannot use the same path to go from any cell to any other cell. Okay, so from this cell to this cell, the person has chosen this path. You cannot choose this path. You have to choose this path or whatever path you want, but you cannot choose this path. Okay, so in this example, they have mentioned this as this horizontal arrow as east and this vertical arrow as south. So you either go east or you go south. So in this example, the example that they have already given, uh, we will have an input number 2. Okay, so that will tell us that how big the grade is, and then a path taken by the person, the path that already has been taken by the person will be given like S or FA. So let's imagine that you have a grade something like I'm not very good at drawing grids, so let's imagine these are the cells. Okay, so this is the first top left cell, and this is the bottom right cell. Okay, so a person has taken up the path S and E. So first the person has went from here to here, and then from here to here. Okay, so the person has taken this path. What you have to do is not take this path and still reach there. So there is one other path which is E and S. Okay, so you have to count with this number E and S. So it's the same way. If you have a grid of 5 cross 5 cells and the person has taken E E S S S E S E, then you have to take some different path to still end up on the bottom right side. So there exists a very easy solution to this. Okay, so what you can do is you start from here, and whatever the person has done, the other person has done, you do just the opposite. Okay, so in this fashion, what you will end up with is wherever the person has ended up with, you will end up at exactly the same location, but you will not take any path that the person has taken if you do just the opposite. Okay, so if you implement this, I've implemented this already as part of the contest. So taken the input, looped over the test cases, and got the number, doesn't really matter, and got the string, the char array of got the char array of all the path that the person has taken, like for example in this case E E S S S E S E. Okay, so I've got the char array, and then I've created a variable, out variable, which I'll store the output, and this is the core logic, the 3-line core logic. So all it does is that it loops over all the character of the char array, and just wherever it finds an E, it turns it into it outputs an S, or if it finds an S, it outputs E. So just the opposite of what is there. Okay, so in this fashion, we'll just output the whatever we have. So in this case, we just run the program. Okay, so we'll have this ES, and the for second one we have SE, SSE, SES. So exactly the opposite. So, and this works. Okay. So you in this fashion you can solve this problem. So this is also another very simple problem. This qualification round was very simple. So I think most of you would be able to solve this problem. May have already solved this problem, or be able to solve this problem. So one more thing I want to discuss is the first problem. I've used this big integer and subtraction things there. So the thing is that you can run a program which does not include big integer or its subtraction multiplication functions. So you can do without using big integer. Okay, using just strings. That is possible, and that will actually run faster than this using big integers. So I invite you to write a program which does not include big integer and which runs faster than this program. Okay? So if you find the solution, if you are able to do this, please send an email to me. The email ID is given in the description below. Okay, so and the same thing here. Okay, If you find a faster solution that works even better than this solution, then please do send me the solution. Okay? Also describing in a few lines that how exactly it works. Because if you go back to the first problem, this solution works in log n. Okay, so if you open the problem again, there we have the maximum input size as 10 to the power 100. So if you and since we are looking over the size of number, we are not looking over the number itself. We are looking over the size of number. So that means the size is 100, since log 10 to the power 100 is 100. So this program runs in log n. So if you can find a program that runs in better than log n, then you are invited to write a program and please send me the program itself. And the same goes for this previous maze solution. If you find a program which works better than this solution, then please send me the solution. Maybe I'll show that solution in the next video. Okay. So the next problem was this cryptograms. Okay. So let's open the problem. And yeah, this problem was a bit difficult than the previous two problems, but it wasn't that much difficult. Okay, so if out of 10 I'll give it at around 3.5 maybe. Yeah, it wasn't that difficult, but you have to spend time to understand the problem itself, and then you have to find a way to solve the problem. Then once you find the way, you will be okay. So without reading everything, let me just tell you what the problem is. Okay, so they have a string like this or this. Okay, and the string will contain all of the letters of the alphabet. So the string will be at least 26 character long. Okay. So but it can also contain multiple one letter multiple times. Okay, so it can be at least 25 characters long, but can be more than 25. One character can show up multiple times. So in the test case, if you see the length of the string can be minimum. Sorry, this is not the length of the string, but I'll tell you what this L is. Okay? So it will be at least 25 and 26 or more than 26 the string. Okay? Now what they have done is, for each of the letters in this string, okay, for A, for B, for C, they have assigned a prime number. Okay, if you don't know what a prime number is, it's basically a number that is divisible by 1 and itself, not any other number. Okay, so for A, for example, for this A, they may have assigned a number 3. Okay, for B, they may have assigned a number 11. For C, they may have assigned a number I don't know, 47. Okay, the only thing is that if they have assigned a number for A, a prime number for A, which might be anything, let's say 11, then the assignment of B, I mean whatever number you assign to B, it cannot be less than the number you have already assigned for A. So it is in an increasing fashion. Okay, so for if a number is assigned to A, or if it is 11, then B can not be less than 11. B can only be 13, 17, or 23 or 29, whatever, but it cannot be less than 11. Okay, and the same goes for C. So it cannot be less than B. So the letters A, B, C, D has to have an increasing order of numbers associated with them, and all the numbers have to be prime numbers. Okay, so in this fashion they have assigned 26 prime numbers to all of the letters in the string. Okay, which are in increasing fashion. So after assigning the prime numbers, for example, let's say for C they have assigned something, for J they have assigned something, for Q they have assigned something. So they have multiplied the first two prime numbers. Okay, in this example, the first two letters are C and J. So whatever the prime number that is associated with C and whatever the prime number that is associated with J, they have multiplied these two prime numbers and came up with this number 217. Okay, the same thing goes for J and Q. They have multiplied these two prime numbers and came up with 1891, and the same goes for QU. They got 4819. So if you can imagine that if there are 26 at since all of the letters have to come up, had to show up in the string, so there will be at least 26 characters in the string. It cannot be less than 26. So if you multiply these two and come up with a number, and then multiply these two and come up with a number, then you will have around 25 numbers, not 26, since you are multiplying these two and coming up with one number. Okay, so if you do this thing for all of the characters in the string, you will come up with 25 numbers, not less than that, not more than that. Okay, in this case it will be more than 25. Okay, so that's why that is what it is there. The L is the length of all the numbers given in this line, which they have come up with multiplying two consecutive letters, the prime numbers associated with two consecutive letters. Okay, so it will be 25. I mean, it can be more. It can be as big as 100. Okay, so they can be like 100 numbers here. So in that case, there will be 101 letters in the input string. Okay. Okay. So they have come up with these numbers, which they have given as input. Okay, it is the length of the input, and this is the prime number, that is the maximum that you can assign letter to. Okay, so 103 is the maximum prime number. So in this example, whatever the value you assign to Z, it cannot be more than 103. Okay, so that is not going to be terribly important. We will not use this number in our logic. So they have come up with these numbers. What we have to do is, once we get these numbers, we have to come up with the original string. Okay, so this number actually corresponds to the multiplication of these two characters. This number corresponds to multiplication of these two characters. So they have given us these numbers. We have to come up with the original string. Okay, so how can we do this? So if we see how I have solved this problem is as follows. So let's say if we have this number 217, and this is actually a multiplication of, let's say, any two variables called x into y. Okay, so x into y is 217. Okay, the next number is 1891. Okay, so, and since the next number has to be a multiplication of y into z, because if you see here, the first two numbers were c and j, and the second two letters were j and q. So in this, j is common. Okay, so 217 is a multiplication of x and y, and 1891 is a multiplication of y and z. Okay, so you see a common factor in y. Okay, so immediately what you can do is you can find a greatest common divisor of these two numbers, which is very easy to find using the Eclipse method. It's also very fast. You can find a greatest common divisor of a number as big as 10 to the power 100 very fast. Okay, so which is given here. Okay, with the number that the number can be as big as 10 to the power 100. So you cannot use int or long and anything. You have to use big integer or strings. Okay, so you can immediately just even if this number is like 100 digits long, okay, and this number is also 100 digits long, you can immediately find the GCD of these two numbers, and you will come up with the value of y immediately. Okay, and once you have the value of y, you can immediately divide this number with y and come up with z. And same time, you can divide this number with y and come up with z. And in the same fashion, once you have the value of z. Since this value will be z into some other variable, you can immediately divide this number with by z and come up with that other value. And the same goes for this and this and this and this. So all of the variables, all of the 26 variables will be resolved. So you will have 26 prime numbers by which they were obtained. Okay, so all you have to do is assign a to the least prime numbers in this 26 prime numbers, and assign b to the second least prime number, and assign c to the second least prime number, and in this fashion you will have this system. Okay, so this is all that you have to do. You have to just find the GCD of these two numbers, and once you find the GCD of these two numbers, you can just simply divide that number, this number with that number, and divide this number with the next last value, divide this number with the last value, and you will come up with all the prime numbers, and then you can just right away assign all the characters to the prime numbers since they were assigned in increasing fashion. So that's it. So that's all I have done in the prime numbers. So all I have done is find the GCD of the numbers, the two numbers, and then divided for all of the numbers. I've divided the last value with the prime number, with the composite number, and just found the individual prime numbers, and then I just simply assign the value. Okay, and just print out the value vectors. So if I just run this program here, so we'll have the original letters as strings. Don't worry, I'll send you. I'll upload all these programs to GitHub and share the link in the description below. So you will have all this code in the GitHub location. So this problem I understood how to solve, but I even went as far as solving this problem half the way, but I didn't have I quickly lost interest in solving this problem because I didn't want to solve this problem, but I have the core logic that you can implement your solution. So please solve this problem by yourself. I'll tell you the logic, but solve this problem by yourself and send me the solution in my email address below, and you can stand a chance to win the Raspberry Pi. If you remember the last video that we had a give the Raspberry Pi. So let's just read out. I mean, we'll not just read the problem. I'll just tell you what the problem is, and then you can just read the problem. It's going to be okay. Okay. So the problem here is that they have given a test set. First, this is the interactive problem. Okay. First of all, this is not unlike other problem. It is an interactive problem. You have to send input and then get output from the server at runtime. Okay. So the first line gives you a test case number, that is fine. The second line gives you three integers called n, b, and f. I'll explain what these variables are. Okay. The third line, you have to send a string of 1 and 0. You cannot send anything other than 1 and 0. You can only send 1 and 0, and the length of this string has to be n. Okay, so n is actually the length of the string that you can send. Okay, and it will store this number. Okay, and once you try to get this number, whatever you have stored, it will give you the string, but it will not give you exactly this string. Since they have the system that stores this string, their system is faulty. Okay, so it might not return some variables. Let's say in this example, they are not returning the first and the fourth character. Okay, so once you try to store this and try to fetch whatever you have stored, it gives you 111. Okay, so right away you can say that the first and the third characters are not stored. So right away you can say that this first and fourth index is faulty in the system. Okay, so but since the problem is huge, the n can be as large as 1024 bits, and there can be at max 15 uh, 40 bits. So these actually the 40 bits that are not storing any numbers. Okay, so you can send you have to send at max 1024 long 1 and 0 string, and there can be 15 40 bits in that 1024 pool, and you have to find where exactly is the fault with in just 5 tests. So what constitutes a test? Test constitutes you will send a number and you will get the response back. Okay, so once you send this number and you get this number, this constitutes a test that you are testing the system. So you can at max perform 5 tests, not more than that. Okay, so first time, let's say you send this number and you got some number, and then you understood about the system that okay, maybe some bits at some location are wrong. Then you send this number and the system responds with this number. So you now have more knowledge about the system, that where exactly are the bits missing. Okay? Then you send this number and the system responds with this number. Then so in this fashion you have to find out where exactly is the issue, with where exactly are the bits are faulty. Okay? Using not more than 5 tests. So you may be wondering that if there are 1024 bits and there are 15 bits faulty bits, then how come can I know about all those 15 bits in all those 1024 bits just by using 5 tests? It will take maybe around at least 1000 tests to be able to find out if a bit is faulty or not. But that is the trick. I mean, you have to use your brain to be able to solve this problem. So maybe at around at a level of 10 I'll give this problem at around 4, maybe 4.5. Okay, if you really understand that how to solve. I mean, once you get the core logic, then you will uh, it's not at all that easy to implement solution even if you have the core logic, but yeah, once you understood really well, then it should not be that much of a problem to implement the solution. Okay, so I'll tell you what the logic should be, how you can actually achieve this just using 5 test case, not more than that. So the thing is that the key is this. Yeah, there cannot be more than 15 faulty bits. Okay, so immediately you can divide this 1024 string into a 16 bits. So what you have to do is that first time when you send this 1024 bits, you prepare a string of 16 zeros, then 16 ones, 16 zeros, 16 ones in alternate fashion. Okay, so you send this this 1024 bit long string, and the response you get there, uh, some bits will be missing. Okay, at max 15 bits will be missing. There can be only one bit is missing, or there can be like 5 bits are missing, or 15 bits are missing. So but then once you see the response, there you will see like the first 16 bits are 0, and then this next 15 bits are next 16 bits are 1. But somewhere you will see that not you did not get all 16 zeros, you got only like 15 zeros or 14 zeros. So there you will understand that okay, in this range, let's say a range between 75 and 90, in this range you got only 14 zeros. So you understood that in this range there is one faulty bit. Okay, since the number of faulty bits cannot be more than 15, even if all the faulty bits are in one range, you will get at least 1 0, and then you will be able to understand that yeah, that since I sent 16 zeros on and got only 1 0, that means there are 15 bits in this range. So then immediately you will be able to understand at least the range of the at where the faulty bits are. Okay, next time this now one test is done already. Next time you send not 16 but 8 bits. Okay, so 8 zeros and then 8 ones, 8 zeros and then 8 ones. Okay, so once you send these numbers, since you already had the knowledge that where in the 16 bit range where there is some issue with some of the bits, once you send 8 bits 0, 8 bit 1, then wherever the issue is, you will be able to understand that the you will be able to narrow down your faulty bit, and so that it only exists between 0 to 8 or 8 to 16. Okay. Once you have that information, let's say it is between 0 to 8, that between 0 to 8 you got only 7 zeros and you did not get extra 0. That means the faulty bit is between 0 to 8. Next time you send four alternative fashions. So you send 4 zeros and then 4 ones. So in this fashion you will be able to understand where exactly is the issue is with the faulty bits. Is it between 0 to 4 or 4 to 8? Next time you send 2 zeros and 2 ones, and the next time you send 1 0 and 1 1 1 in alternative fashion. So in this fashion, if you see, first time we send 16 zeros, second time we send 8 zeros, third time we send 4 zeros, fourth time we send 2 zeros, and last and the final time, fifth time we send 1 0 and 1 1. So in this case, you will be able to exactly pinpoint that where exactly are your 15 faulty bits in all of 1024 bits. Okay, so that is the core logic that you have to implement. I tried to implement this, but I didn't complete the implementation. So please write the program in your preferred language and please send it to me. I'll showcase this your solution if it is really good in our next video. So and you will also stand a chance to win a Raspberry Pi, brand new Raspberry Pi. So please try the solution and please send me the solutions. Okay, so thank you. Bye bye.